Hello everyone, my name is Elmer Ibrahim and I am the project manager for our software engineering project presentation based on Bus Asia case study. The presentation is prepared for Dr. Fawziya. We are a group of five members. I am Almeri, CB 25139, the project manager. Safi Noor Aliya, CB 25063 is system analyst. Mutahar Abdul Qadir, CB 25132 is programmer. Hassana Binti Arif, CB 25089 is a tester, and Bavagas Abdurrahman, CB 25133 is a system designer. For today's presentation, I will present question 1 and 2. Mutahar will present question 3, parts A and B, and I will continue with part C. Hassan, Hassana and Safi will cover question 4. Question 5 and question 7 are individual questions, and question 6 will be explained by Bafagas. For question 1, what's Bus Asia? Bus Asia is an online bus ticket platform that connects customers and bus operators in one system. It supports city trips and long distance trips in Malaysia and nearby regions. The main purpose of Bus Asia is to making planning and booking easier. Users can find bus services, book tickets, and manage their trips online. At the same time, it helps bus operators reach more customers and manage their services better. The system was developed in 6 months using a suitable software engineering process model. It also provides electronic ticket and booking tracking, so users can feel more confident after booking. Moving on to question 2, this slide shows the basic steps users follow in Bus Asia. Users first search for a route, then they compare choices like time, price, bus type, operator, and seat availability. After that, they pick a trip, confirm the booking, and pay online. Then they receive the booking confirmation.
In question 3A, website objectives. On this slide, I'm explaining the main objectives of the Pulse Asia website. The primary goal is to modernize and simplify bus transportation services in Malaysia, especially in Sarawak. Bus Asia aims to act as a central hub that connects between passengers with bus operators in one platform. It also focuses in improving operational efficiency, especially for cargo-related services. Another important objective is to reduce waiting time and minimize manual paper ticket errors by moving to a more digital process. Overall, these objectives support the growth of a more reliable and efficient digital transportation marketplace. Okay, next in question 3B, information services. In this slide, summarize services, key information services provided by Pass Asia. First, users can do ticket booking through a structured search process where they can choose routes based on date and time. Okay. Second, the website provides timetable information so users can easily check operating hours and departure time, especially for city buses. Third, Bus Asia includes GPS tracking, which allows real-time bus location monitoring to improve user trust and reduce uncertainty. Finally, it supports cargo services where user can check shipping option and pricing based on distance and weight, including door-to-door delivery options. Together, these services make the platform complete for both passengers and cargo customers. So let's move to our classmate in question 3C.
I will continue in part C. Bus Asia is not just a normal website, it handles real bookings, schedules, and payments. so it must be built carefully and in an organized way. Software engineering helps make the system reliable, so bookings and schedules work correctly. It helps with performance, so the system can handle many users at the same time. It improves ease of use, so the booking steps are simple and clear, and improves security, so user and payment information stays protected.
The software process model chosen for the bus access system is the incremental development model. This model is suitable because the bus access system consists of multiple functions such as ticket booking, route searching, cargo services, payment processing, and also GPS tracking, which can be developed and delivered in stages. The incremental development model allows the system to be built and delivered in small, functional parts called increment. Each increment provides a working version of the system with added features. This is suitable for Bus Asia because the users can start using core features such as ticket booking and route search early, while additional features like cargo services and GPS tracking can be added in later increments. Another reason for choosing this model is that it supports early user feedback. Users are able to test each increment and provide feedback, which helps identify problems or missing requirements at an early stage. This reduces the risk of major changes later in development and improve overall system quality. Overall, the incremental development model provides flexibility, reduces development risk, and ensures that the bus access system can evolve gradually while still meeting user needs. Next, the incremental development model consists of four main process activities, such as specification, design and implementation, validation, and evolution. These activities are repeated for each increment of the bus access system. The first activity is specification. In this phase, system requirements are gathered and documented based on user needs and business objectives. For the bus access system, this includes requirements such as online ticket booking, seat selection, route information, cargo delivery services, GPS tracking, and secure payment methods. The requirements are prioritized so that the most important features are developed first. The second activity is design and implementation. During this phase, system designs are created and the features for a particular increment are developed. Developers implement the required functionalities according to the specifications. This will ensure that each increment delivers a working part of the bus access system. The third activity is validation. After an increment is completed, it is tested to ensure that it functions correctly and meets the specified requirements. Testing helps identify defects, errors, or missing functionality before the system is released to users. Last but not least, the final activity is evolution. In this phase, feedback from users are collected after the increment is released. Improvements, changes, or additional features are planned and implemented in future increments. This allows the bus access system to continuously improve over time.
Next, I will explain the project deliverables for our Bus Asia system. These deliverables are produced based on the incremental development model and they are divided into four main activities: specification, design and implementation, validation, and evolution. Specific based on the For the specification phase, the main deliverable is the software requirement specification or SRS document. This document defines what the Bus Asia system must do. It includes functional requirements such as route search, ticket booking, seat selection, online payment, e-ticket generation, and booking tracking. That we also produce use case diagram to show how different users such as passenger, bus operator, and system administrators interact with the system. To make sure all requirements are tracked and verified, a requirement traceability matrix is created. Next is the design and implementation phase, where the requirements are converted into a working system. The main deliverables here include the system architecture diagram and database design such as ERD and database schemas which explain how data like users, roles, booking, tickets, and payment are stored and connected. For the validation phase, the focus is to ensure the system works correctly and meet user requirement. The deliverables include a test plan, which define the testing strategy, scope, and environment, followed by detailed test cases for individual function and system integration. During testing, a defect or backlog and test execution report are produced to record issues, severity levels, and fixes. Lastly, the evolution phase focus on maintaining and improving the system after release. The main deliverable is a change request log which records new features requests and improvements from user and stakeholders. We also produce release note and maintenance report to document bug fixes, system updates, and newly added features. Next, I will explain our project Gantt chart for the Bus Asia system. This Gantt chart is constructed based on the incremental development model, which allow the project to be developed and delivered in manageable iteration. Overall, the Gantt chart shows the entire project lifecycle of about 6 months, starting from mid-December 2025 until mid-June 2026, covering all major activities from requirements until deployment and monitoring. The project begins with the requirement phase, which runs for about 2 to 3 months. During this phase, activities such as requirement gathering, identifying functional and non-functional requirements, defining use cases, and main system function are carried out. This phase is important because it ensures that all necessary user and system requirements are clearly identified. Next is the analysis and design phase, which overlaps with the requirement phase and lasts for around 2 months. In this phase, we focus on defining system components, designing components, refining design, and performing additional design work. After that, the project moves into the implementation phase, which also spans around 2 months. This phase includes developing prototypes, developing system modules, implementing backend APIs, and features development. Then testing activity begin while implementation is still ongoing and continue for about 2.5 months. The testing phase includes prototype testing, unit testing, integration testing, non-functional testing, and user acceptance testing. This ensures that each increment is validated before the system evolves further, which is a key principle of the incremental development model. Finally, the project enters the deployment phase, which lasts for about 1 month. This phase includes deploying Bus Asia into the live environment and performing post-deployment monitoring to ensure system stability, performance, and reliability.
For question 5, from the project manager perspective, a major handover issues in Bus Asia is weak documentation and poor knowledge sharing. If the system is handover without update diagrams and clear instructions, the team that will maintain it may not understand how it works. This can cause confusion, slow problem fixing, and higher risk when we want to add the new features later. To reduce this, we should update the documentation after every increment and update it one shared one shared place, so everyone uses the latest version.
One major handover problem in the bus access system is incomplete or outdated system documentation during project transition. As the system analyst, I am responsible for producing requirement specifications and ensuring they remain updated throughout development. However, in an incremental development approach, system features are continuously added and modified. If requirement documents are not updated after each increment, the team receiving the system during handover may misunderstand how certain features are intended to function. For example, modules such as ticket booking, route selection, cargo services, and GPS tracking may have undergone changes based on user feedback. If these changes are not clearly documented, developers and maintenance team may implement updates incorrectly or fail to maintain system consistency. This can result in system errors, integration issues, and increased debugging time. Therefore, poor documentation handover can lead to higher maintenance costs, delayed enhancements, and reduced system reliability. As a system analyst, ensuring accurate and complete documentation during handover is critical to maintaining long-term system quality.
Okay, question 5. As a programmer, Mutahar Abdelkader IDCB 25132. As a programmer, one major handover problem identified in the PAS Asia project is the lack of clear technical handover between development increments. This mainly happens due to missing or incomplete API documentation. When technical details are not properly documented, new programs spend more time understanding the existing code, which increases development time and cost. This problem also affects system quality as poor handover can cause integration issues between key modules such as ticket booking, payment processing, and cargo tracking. For example, in Bus Asia, if changes are made to the seat number or booking API without proper documentation, the next development team or member increment may face delays or introduce error. Therefore, proper technical handover is essential to ensure smooth incremental development and system reliability. So let's move to our classmate.
As a tester in the Bus Asia project, one key handover issue I identified is unclear and inconsistent testing documentation when new increments are passed from the development team to the testing phase. Because Bus Asia follows an incremental development model, new features like booking, seat selection, payment, and GPS tracking are introduced gradually. Each of these must be tested carefully before being combined with existing features. So, what it impact on the project? This issue will if not only affect testing but also the project timeline. When information is unclear, I may need extra time to clarify requirements and repeat test case, and this delay can build out across multiple increments. It also affects the early feedback process, which is one of the main advantage of using the incremental model. In the long term, missed issue during early testing may only be discovered after deployment. This increase maintenance effort and make future improvement more complex and costly.
About my part, I will discuss a key problem faced during incremental system development. The main issue is poor, inconsistent, or outdated design documentation. When documentation is not updated after each incremental, new developers, testers, and maintenance teams may misunderstand the system structure and component interactions. This can result in incorrect implementation, incomplete testing, higher maintenance cost, and reduced system stability over time. Now we will move to the another questions. Okay, let's go to the question number 6. My part system architecture model. For question 6, Bus Asia uses the model view control architecture. The model stores data and handles system logic. The view shows information to the user, and the controller manages user requests and controls how the system works. And the picture in the right about my work. There's two reasons about why I use MVC architecture model. The first one, separation of concerns. MVC separates the system into clear parts. Each part it has own responsibility. The changes to the user interface do not affect the system logic. The second reason, scalability and user experience. MVC make the system easy to expand. A new feature can be added without changing the whole system. It also helps business handle many users smoothly.
For question 7, involving users early in release testing gives two main benefits. First, it gives an early check to make sure that we are building the right system, and it helps us to catch mistakes before they become expensive to fix. Second, it improves user acceptance because users get used to the system before the final release, so deployment becomes smoother. However, one disadvantage is that too much user feedback can cause delays if it is not managed well. So, the project manager should prioritize feedback, fix important issues first, and plan the rest for a future release. That concludes my part of presentation. Thank you, and I will now hand over to the next presenter.
The first benefit is accurate requirement validation. By involving users early, the system analyst can confirm whether the documented requirements truly reflect user needs. Users can interact with early versions of the bus access system and highlight missing features or usability issues, reducing the risk of incorrect requirements being carried forward. The second benefit is better requirement prioritization. Early feedback helps the system analysts identify which features are most important to users. This allows feature increments to focus on high priority functionalities, such as improving booking efficiency or enhancing payment security, leading to a more user centered system. However, a key disadvantage is scope creep. When users are involved early, they may request additional features that were not part of original project scope. If these requests are not properly managed, they can increase development time and cost. As a system analyst, it is important to control changes and schedule enhancement appropriately to ensure the project remains on track.
Okay, question 7. The programmer Mutahar Abdelkader ID CB25132. Question 7. From a program's perspective, involving users early in release testing provides two main benefit. First, it helps identifying usability and functional issues early, such as confusing booking flows, unclear tables, or problem with cargo tracking. Second, um, it validates actual users' need by confirming that the system meets real user expectations rather than developer assumptions. However, one major disadvantage during the validation and verification stage is that excessive user change requests can increase complexity and disrupt the planned incremental development schedule if they are not properly controlled. For example, in Bus Asia, the early user feedback can confirm whether the booking, payment, and tracking feature match how passenger actually search, select seats, and complete transactions in real use. So let's move to next our classmate.
From my role as a tester, the first benefit that early user involvement help us validate real user needs and system usability. This is because most internal testing focus on checking whether the system works according to the specification. However, this does not always reflect reflect how real users actually use the system. When users are involved early, I can observe how passengers interact with the bus access system. Is the For the second benefit is finding issue in real user environments. From a tester point, it is difficult to fully stimulate real-world condition in a testing environment. Users may access the system using different device, process, or network condition. However, there is also a disadvantage for involving users during the testing stage. One main concern is the possibility of unplanned change and delay.
About my part, I will explain the benefits and disadvantages of user involvement during validation and verification. Benefits: user involvement helps check if the system meets real user need. Also, it helps find usability problems early, such as navigation or booking issue. Fixing problem early save time and cost. About the disadvantage, however, involving user can increase project cost. It also takes more time to manage feedback and design changes. And thank you for your attention.